Hello everyone, today we're going to introduce a new type of transformation which is called dilation. So if you remember in last unit we introduced three transformation which are translation, reflection and rotation, and we also call them rigid motion because they keep the shape same size and same shape, so nothing changes for after the transformation compared to original pictures here. Today, we are going to introduce this transformation called dilation. It's quite different compared to rigid motion. So let's see more details of this. So first, let's see some examples here. So if you pay attention to all the pictures here, you'll probably notice a common thing is no matter it's pizza boxes, dolls, or um, the pictures here, everything is the size changes. Is it getting bigger or getting smaller? But the shape stay exactly same. No matter we're talking about 3D boxes or 2D pictures here, they're all same thing because the shape is not changing. So for this kind of transformation, we have the name for that, which is called dilation. So as you can see, you actually see a lot of example in real life about dilation. So dilation is kind of a transformation. The sizes of the picture does change, however, the shape stay the same. So that's the most important feature of dilation. So now let's see more details about dilation. Dilation is a transformation that makes a figure larger or smaller, but has the same shape as the original. So you can definitely pause here and take notes here. So it will be easier for you to review this concepts in the future. And also let's just pause here. As we mentioned here, also has the same shape as original. Remember, just like what we mentioned before, original picture we have name which is called pre-image, and the one after the transformation we call them image. So this kind of concept still stay the same after transformation. And for example, one of the points on the pre-image I labeled as A, then on the image I can match it to A prime. So this kind of concepts still stay the same. And as we mentioned, so the most important thing we need to know about dilation is sizes change. However, the shape will stay the same. And also oftentimes we have two types of dilation. One is when the picture getting bigger, which is called enlargement. The other one is when the picture getting smaller, it's going to be called reduction. So it's kind of straightforward from the words, right? So now let's check the bottom picture. You can see, please focus on which one is pre-image. So now can compare the one after to original one. So the pre-image for the penguin, as you can see clearly, is getting smaller, so it's reduction. And for the USA map here, the pre-image is small and is getting enlarged. It's like dilate the picture, then it's called enlargement. So this kind of example, is very common to see, and which is our all dilation. Now, when we talk about dilation, we always mention two things. One is called center of dilation. Center of dilation sometimes is not easy to see from the picture, and sometimes you have to go back to connect the lines here, and every single thing is back to the one point. This is called center of dilation. Is where we where is the center we use it to enlarge or reduce the size of the picture. Another one you will often hear is called a scale factor. So scale factor is amount by which the image grows or shrinks. So it's kind of ratio. It's like, for example, you take a picture. You are going to graduate. You take a picture and you wanna make it larger, so you can put a very beautiful frame on that. You can put it in the put it at home, or you can shrink the picture to a very small size. You can put in your wallet. So this kind of steps here is called, we can use scale factor to see how much is enlarged. Is it like it's getting 2 times bigger or 3 times bigger, or is just get half size of this. So this kind of number you hear is called scale factor. And one more thing, just want to remind you, we just use k to represent the scale factor. So sometimes if I just say k equal 2, then just basically meaning 2 is the scale factor is getting 2 times bigger. So it's something you can relate to. Now, today the focus will be on how do we calculate scale factor. So the scale factor, the very easy formula to remember is image over pre-images. But if you just really see this formula, probably it's a little bit weak. Like, what is image and how are we going to use image to over pre-image? It's like we are dividing two pictures. Of course, it's not like that. So we are going to look at these two examples, and then we are going to use example to figure out how do we calculate scale factor. And later we can even summarize what kind of scale factor can predict the type of dilation. Okay, so now let's check the picture on the left. So as you can see, we have two triangles here. The blue one is PRQ, and the green one is P prime, R prime, Q prime. So as we mentioned, the most important thing, the first thing is we figure out which one is pre-image, which one is image. And as we mentioned before, on the before one, we just use the original letter to label this. And after transformation, we use prime. So as you can see, I noticed there is a prime here. So that's why this is image. Sorry, this is image. Somehow my pen is not really working well. Okay, let's write it down. And this one is pre-image. So I just use pre here. So it's like from blue to green one. So now, since I know scale factor is, we're gonna figure out how much is shrink, how much is, enlarged. So this small picture getting bigger, so I know it's gonna be enlargement, right? It's like very straightforward. We can just compare the size. And then scale factor is going to say, I need to figure out, so the way we use it, I use one side of the scale, the image, and compare it to the corresponding side. So let's check P prime R prime. So this is 1, 2, 3, 4. So it's 4. This is image over. And I use PR, of course, I'm going to use P prime R prime. I'm going to use PR in original one, so which is 1, 2. 2 equals 2. So that means this scale factor is 2, and meaning the picture is enlarged by 2 times, right? So some student might say, can I use RQ? Yes, of course. So let's use this one to prove this is actually correct. So R prime Q prime, which is 1, 2, 3, 4, 5, 6. And 1, 2, 3 over 3. So you will get exactly same thing, which is 2. So no matter which size you use, you will definitely get to the same answer. However, I wouldn't suggest to use P prime or Q prime because this is, this slanted line here is not easy just to count by units, by spaces. So it's not a good idea. Now let's check this one. This one is, we see the two polygon here. So the first shape is original one is the blue one, apparently compared to the green one is smaller. So it's a bigger one. The pre-picture, pre-image is bigger one. So that's why this is reduction. So now, still we are going to use image over pre-image. Since the image is on the top, so we are going to focus on the bottom one. So let's just use this little side here is 1 over. Same thing, we are going to 1, 2, so it's over 2. So it's half. You can simplify this as 0.5. It's say the same. So this time the picture is getting smaller. As you can see, this number is like a small number compared to 1, right? So if you use mn, same thing. So it's 1, 2. So this is 2, 1, 2, 3, 4. This is 4. So you will simplify as 1, 2, or same as 0.5. And if you pay special attention, it seems that scale factor can even we do not see the picture, we can just quickly use scale factor to predict the dilation. So let's summarize here. So as you can see, when scale factor is a bigger number, dilation is actually enlargement. And when the scale factor is a smaller number, is reduction. But we cannot just say bigger or smaller because you have to compare a number. So what we do here is when scale factor is greater than 1, then the dilation is enlargement. Let me write it on here. So some students, if you forget this symbol, you will remember this. And of course, this is less than 1, then it's going to be, but of course, please remember this less than 1 but greater than 0 is actually, so less than 1 greater than 0, because we do not deal with negative scale factor in this situation. So that's why sometimes if you use your cell phone to take the picture, when you zoom in, you will see a number on the side to tell you 1.6, 2.6. This is how much you enlarge the picture. So some student might say, then what if this scale factor is 1? What happened to that? So you can definitely think about this. If we are talking about pre-image over image is 1, meaning what? For example, 2 over 2 is 1, 4 over 4 is 1, meaning we are actually comparing exactly same size, right? Then pictures are, yes, you probably figure out the idea, congruent, because they are stay the same, nothing changes. Okay, so that's everything I want to share with you about dilation. This is just very brief introduction regarding scale factor, and the keywords here, scale factor, is we need to know how to find the relation and how to calculate this. I hope this video is helpful for you to understand these terms. Thank you so much for watching this video. See you soon, everyone. Take care.